So in this video, we're going to go through sample question 79 from the Society of Actuaries ExamP list of sample questions. The question reads, a device contains two components. The device fails if either component fails. The joint density function of the lifetimes of the components measured in hours is f of st, where s is between 0 and 1 and t is between 0 and 1. So it tells us, okay, joint density function and the component will fail between 0 and 1 hours, it seems. We need to determine which of the following represents the probability that the device fails during the first half hour of operation. Huh, neat. So this is actually a good problem to talk about why drawing pictures are super helpful. All right, this is more of a conceptual question. So what I'll do is I'll kind of draw a little XY axis, or an ST axis, I guess, depicting the graph of this function. So S here, T there, and S goes from 0 to 1, T goes from 0 to 1, and we're looking for the probability that the device fails within the first half hour of operation. And the device fails if either component fails. So T can fail at time 1/2, and S can fail at time 1/2. And I'm going to draw a little dot here, something like this. And what you might be able to see is we've kind of split this graph up into 4 sections. All right. In this section, we have where both S and T fail within the first half hour. I'll just kind of actually use different color markers. In this section up here, we have S and T where T fails within the first half hour, but S does not. Right here, I might have said it wrong before, but this is where S fails within the first half hour, but T does not. This is where T fails within the first half hour, but S does not. And then we have here where both manage to make it past the half hour mark. Now, if we fall into any of these 3 boxes, what's going to happen is the component won't fail, right? The machine will stop working. So let's look for which set of, I suppose, integrals, which set of integration gives us that range, right? If we look at answer choice A, 0 to 0.5 for ds, so from here to here, and then here to here, this boxed in range. So it's not answer choice 1, right? Eliminate that. Now we're looking at, let's see, 0 to 0.5 for ds, so here, and 0 to 1 for dt. So just this section. We're missing this green section here. So it's not B. 0.5 to 1 ds, so up here, great. Right, and then 0.5 to 1 dt, so here, which, not it, right? So that's just this section here. Now, here, we have 0 to 0.5, and then 0 to 1. So 0 to 1 on ds, here, and then what is that, 0 to 0.5 for t here. Doesn't cover the full thing. And that leaves us, oh, and of course we're adding in 0 to 1 and 0 to 0.5 ds dt. So that's here and here. That doesn't cover the full thing, right? Now, looking at the last one, we have 0 to 0.5, or sorry, 0.5 to 1 on ds, so here, and then 0.5 to, or 0 to 0.5 for t, so here, which just covers that section. And then we're adding on 0 to 0.5 on ds, so that would be here, and 1 to 0 for dt, so that would be here. And that actually does, in fact, cover the entire region. So our answer choice would be C. Okay, so what's important to note is that the shaded region here, right, the stuff that we're looking for, is the portion over S and T where the device fails sometime in the first half hour. Okay, so this first integral entirely covers this box, this green box here, right? This second integral that I'm adding onto it entirely covers these two bottom sections here. And that's just kind of a good example if you look at question 77, right? That's exactly what happened in that question. We drew out a graph and we're kind of looking for our overlapping regions. Okay, if there are any questions, anything you want me to clarify, throw something down in the comments. I'll answer to the best of my abilities. If you want to see more problems worked out like this, please just, we have a playlist, right? Off to the side, you'll see it towards the end of the video. And if this video helped you out, hit the like button, because that totally helps me out. But other than that, good luck.